In this lesson we're looking at integrating squares of sine and cosine. Examples. In the first one here we need to find the integral of sine squared x dx. Now with these type we're going to consider cos 2a, okay, the expansion of cos 2a, which of course can be written as cos of a plus a equals cos squared a minus sine squared a. Now because we are dealing with sine squared, what we're going to do is replace the cos squared. We replace cos squared a with 1 minus sine squared a. We've got that minus sine squared a as well. End up getting 1, and minus sine squared a minus another sine squared a, of course, is minus 2 sine squared a. Now, cos 2a equals to 1 minus 2 sine squared a. I need to get the sine squared by itself. So let's just write that down for a moment. Now, the minus 2 sine squared a, bring that to the other side, becomes positive. And we're going to take the cos 2a over and bring that to the other side, becomes minus. End up getting that 2 sine squared a equals 1 minus cos 2a. At this point, let's divide that by 2, divide everything by 2, so we get that sine squared a equals 1/2 of 1 minus cos 2a. So that said, the integral of sine squared x then, let's write that down, we replace the sine squared with 1/2 1 minus cos 2a. So it's not a this time, of course it's x, so it equals the integral of 1/2 times 1 minus cos 2x dx. At this point there, let's write the half out. The integral of 1 is simply x, and integrating minus cos 2x we get minus 1/2 sine 2x plus c, our constant of integration. Our next one, we need to find the integral of cos squared 3x dx. This time we've got some limits. The limits pi on 6 and 0. Okay, again, we start off with the cos 2a expansion. So for both sine squared and cos squared, we're going to start off like this. So we're going to write that as cos of a plus a, which is cos squared a minus sine squared a. Now this time, because it's dealing with cos squared, we're going to replace that sine squared a. Okay, we're going to get rid of that. So one thing at a time, the cos squared a, write that down, minus sine squared a, we're going to rewrite as minus 1 minus cos squared a, make sure that's in brackets. So we've got cos squared a minus cos squared a, ends up being plus cos squared a, so we've got cos squared a plus cos squared a, which is 2 cos squared a minus 1. Now, that's what cos 2a equals, cos 2a equals that, let's write that down. And we're trying to get cos squared a by itself. So we'll bring that minus 1 over, become plus 1. So we'll end up getting that 2 cos squared a equals 1 plus cos 2a. All right, looking at that, we want to get rid of that 2. Let's divide everything by 2. And in doing that, we get cos squared a equals 1/2 times 1 plus cos 2a. Now, the question involves cos squared 3x. Okay, now you might intuitively know what that's going to be, but I would take an extra step here and show you. Cos squared 3x, basically that a replace with 3x. So we're going to get 1/2 times 1 plus cos 6x, because the 2a, all right, 2 times a, 2 times 3x gives us that 6x. Okay, I would suggest that you take that little extra step there. So the integral then, let's write that down. So we write down our limits, pi on 6 and 0, and the cos squared 3x, we're going to replace it with what we've just found. So let's write that down. So the half, again, that's the constant that just goes out the front there. Okay, then integrating, we've got 1. Integral of 1, of course, is x. And the integral of cos 6x is 1/6 sine 6x. Okay, again, we're using limits for this particular question. Let's write that half down and our box brackets. Now, that particular term, if we substitute the pi on 6 for x, we're going to get pi on 6 plus 1/6 times the sine of pi minus, and then our expression there, substituting the 0 in, we actually just get 0. Once we put that 0 in, you can check that out if you're not too sure. At this point, good to understand that 1/6 of sine pi, well, sine pi, in other words, sine 180 degrees is actually 0 as well. So let's just cross that out. So we're just about there. 1/2 times pi on 6 ends up being pi on 12. Terrific. Next example, we need to find the volume generated when the region bounded by y equals cos x and the x-axis between x equals 0 and x equals pi on 3 is rotated about the x-axis. Well, the solution there, the y equals cos x, might just draw a little quick sketch here. Doesn't have to be super accurate, but there is our little y equals cos x graph. It's only a little bit of it because we're only going between 0 and pi on 3. Okay, we haven't seen much of the graph there. So let's just mark in there, shade in our region, and we're dealing with volume about the x-axis. So the volume about the x-axis, of course, volume equals pi times the integral of y squared dx. So therefore volume equals, okay, let's write our pi down, and the integral of y squared dx, where y equals cos x, so we'll get the integral of cos squared dx. And of course our limits, 0 and pi on 3. So again, write the pi down, there's our integral sign. Now cos squared x, okay, now we've seen from the previous questions there that we can replace cos squared x with a half times 1 plus cos 2x. So we've got the pi there, we've also got that half, that can come out as well. So we'll end up getting pi on 2, and the big box brackets there. Integral of 1 is x, integral of cos 2x is 1/2 sine 2x. Okay, put our limits down. So let's put our pi on 2 down again in brackets. Now let's do the substitution. We need to put pi on 3 where we see x, so let's do that. Minus, and then the 0 when it goes in, we'll actually be subtracting 0 again. Okay, once you put 0 in there, there's nothing happening. So pi on 2, let's write that down. Then we've got pi on 3, and then 1/2. And what is the sine of 2 pi on 3? Well, that's one of those exact ratios. Ends up being √3 on 2. All right, of course, we want to always answer in exact form where possible. So we've got pi on 2 multiplying by that pi on 3, we get pi squared on 6. And then the pi on 2 multiplying by that term, end up getting plus √3 pi all over 8. Now, of course, it's a volume, so make sure that we put the brackets around that and answer as units cubed. Excellent. Well, that concludes the lesson. Good luck with your questions.